to programming, and we've also tested some basic programming in C++. All right, so we've done that. Of course, I believe that by now you're still not fully, quite a number of you will still not feel, how do I say? You're not feeling comfortable. Yeah, some of you may not be feeling comfortable with learning about programming because apparently it is a new thing for you. But nevertheless, for now, let's get along with that. Later on, you will fully understand. Yeah, you will be fully. Well, for now, it's likely to sound difficult, but later on, as we pick up on the programming part, you will feel more comfortable with learning programming, especially in C++. So today we are going to go slightly more into what we've covered previously. Yeah. We've covered about this. We've covered about quite a number of things. We've covered about program development life cycle, right? The three most important parts in the program development life cycle that includes input, process, and output. We've done input, we've done output, yeah. And we've also covered about the design. Yeah, notice. First is to calculate and display age. For example, here, get year born and current year. This is the algorithm. Calculate age. Age equivalent to current year minus year born. Print or display age. So that's the algorithm. The pseudocode looks almost similar to the programming language, but still very much English. Now that we have begin and end, yeah, and this is the flow chart. Flow chart also looks similar to the pseudocode, only that it is represented in a graphical form. Implementation is when you do your coding, testing, and maintenance. Of course, we covered about testing, which is what? We test the value that the user has entered to make sure that despite having different values, the program will still manage to run, right? And maintenance, of course, for big projects especially, you need to maintain to ensure that the program is running perfectly, yeah, without any glitch, so that no big problem will come after you. Now we stop here. We did not cover about basic control structures, but then again, by doing the other program using the block lead codes, if you remember correctly, we've covered some basic control structures, didn't we?
Yes.
Yes, we have. Yeah, basic control structures. What are the control structures? Let's have a look at the definition. Program control structure controls the flow of execution of program statement. The C++ provides structures that will allow an instruction or a block of instructions to be executed, repeated, or skipped, depending on the situation. So this is how we control. Yeah, by now you may have noticed that the program is running in sequential manner. That is one line at a time, isn't it?
Yes.
Yeah, the program code will run one line at a time, such as this. Notice here, this is where the program starts, void main, curly bracket. That's where it starts. Here, integer, year born, integer age, integer current year. These are the variables. What is the data type of this variable?
Integer.
Integer, int, is represented by the data type integer. Can we put char?
No.
Why not?
Because we cannot do arithmetic with it.
we cannot perform arithmetic calculation. If you were to put char, you still get the values. But then again, you cannot perform arithmetic operation. Why is it necessary for arithmetic operation?
So we can do
There you go.
calculation.
There you go here. Yeah. Age is equivalent to current year minus year born. We want to perform calculation. So when we want to perform calculations such as this, we need the value to be an integer. Isn't it?
Yes.
Next, after we perform that, the program will move to the next line. C out. Please enter the current year. What does C out do?
What we call output.
C out is to output to the monitor, to the screen.
Yeah.
Notice the arrow. Yeah, notice the arrow. Arrow is heading to C out, so that C out can display. What to display? These are the text. Yeah, these are the text that C out will display. After this is being displayed, it will move to the next line. C in. Yeah, notice the arrow. Yeah, notice the arrow is going this way. So the arrow says current year. Current year is a variable here. Current year is a variable. Yeah, you introduce the current year first, then only you can use the current year. When you say C in, it will expect the input, yeah, from the user. The user will have to enter the input in numbers. What happens if the user put in character?
Error.
Of course, in this case, it will still accept, but it will yield error. Okay, we'll cover about the different types of errors. Next, it will move on to the next line. Display, please enter year born. Next line, expect the input from the user to enter the year born. Then it will be placed in the variable year born. Next, move on to the next line, perform the calculation. Yeah, store the results of the calculation into yet another variable. After we perform the calculation, move on to the next line, display the result. Notice here, what is this sign then? This is also called the concatenation. You concatenate the string and the variable into C out to display. Okay, not only that you want your age is to be displayed, but you also want the value of the variable to be displayed as well. So you have to put another arrow sign so that they will be displayed together. Any question? In this case, the program performs sequential structure, one line at a time. So in doing the programming, the basic is the sequential structure. But then again, you can have other control structures to help you manage your program. Yeah, what other control structures available besides the sequential structure? We have the selection structure. The selection structure is done by making a choice, which is called a branch. And next, we also have the repetition structure, which is by executing a statement over and over using a structure called a loop, or by calling a function. So the repetition structure repeats itself until it reaches a predetermined number of loop. Okay. Now, a big picture. No, or perhaps some explanation in detail. On the sequential structure, it is the simplest of all structures. Of course, you understand. It has a start, it has an end. It will go through one line at a time, yeah, until it gets to the end of the program, which is fine, yeah. common. But here, we have a selection structure. Suppose that while doing this, after statement 2, you want to decide, you want user to decide perhaps what you want to do with that. So we'll come to here. It will have, the program will choose, or the user will choose whether it's going to be true or false. Yeah, it's either or. If the comparison is true, it will go through another way. If it is false, it will go through another way. That is the control structure for selection. Yeah, you select which one. How do you do that? For example, okay, for example, let me start a program. What's it called? What's it called? Dev.
Dev.
There you go, Dev C++. Let's create a new one. So we have now for those of you who are not familiar yet about this, you by now I believe that you somewhat understand. A C++ program has a default structure. What is the default structure? First, you have to include the library that you want to use. What are the libraries? The most common library is the IO stream. And to include a library, you start with a hashtag. Include IO stream. It's not iOS, but IO stream. Okay? IO is for input-output stream. Next is, since we do not want to keep on repeating on typing the std, because that will be the most common namespace that we want to use, you start typing using namespace standard. Always. Yeah, sometimes you may have to use a different library, but we'll start doing that, no worries. Now, here, the common practice is to use integer for the main. Despite in the example it was showing void. Void is when you do not return anything. Integer means the program will return an integer after the execution. That's the difference. Okay, the common standard C++ programming is returning an integer. So we'll follow the standard. Hence we put integer main. We start the coding part with a curly bracket. This is the common structure that you must remember. Okay, this is the common structure that you must remember. Now, yesterday, we declare a name. Oh, not yesterday, but the day before yesterday. We declared a name that the user can enter, didn't we? So, name 20. There you go. It's a variable that we want to store our data. Now move along. See out. We want the program to show something so user can, or basically we give hint to the user what to expect, or what do we expect. Name. See in. That arrow. Name. Did we do this yesterday? Or the day before yesterday?
Yes.
Yes, we did.
Yeah.
Yes, we did. All right. See in name. And what's next? We see out. Anyway, we see out. Hello. Name. Ideally, you type in return not. But even if you did not put that, it's fine. Yeah, even it's still working. Now, when we compile and run the program, what will happen?
It will ask for our name.
Hello. Yes. Okay. There you go. Name Suhardi. It will display hello Suhardi, depending on what we have entered. Now that we want to implement, if the user is Suhardi, we display hello Suhardi. If the user is not Suhardi, or even in your case, whatever is your control, you want to display hello that particular name, you are not Suhardi. Understand? How do we go about doing that?
We use if.
We use if it is selection control structure. Right here, after the user has entered into the variable, we can perform the comparison, the selection. If name equal to Hardy, see out hello name. Else, see out Ctrl C, Ctrl V. Perhaps I put a new line. I put a new line for you are not so hardy. Let's try to run and compile and run. Suhardi. Hello, Suhardi. You are not Suhardi. What happens?
You forgot to capitalize. I don't know what happened.
Does anyone have any idea?
No.
Because now we are dealing with a string of characters, isn't it? When we're dealing with string of characters, we have to do something else. Instead of doing normal comparison like this for the selection, we need to use another function called strcmp, string compare. Right? Name, comma, Suhardi equal not. If they are equal, then only you can proceed. All right, there's a problem. Notice underneath here, it says string compare was not declared in this scope. All right, if you are trying to do the same thing, don't you get the same result?
Yes.
Yes, string compare is not declared in this scope. Why is that? Because string compare is a function in another library.
Oh.
If we did not include that library, we cannot use string compare. So we include the library. Include string.h and start to compile and run again. There you go. Suhardi. Hello, Suhardi. Run the program again. Ahmad. Hello, Ahmad. You are not Suhardi. Yeah?
Yeah.
When it comes to here, it does the comparison for the selection. It will select. If it is true, then display this. If it is false, then display the other. Yeah? That comes back to here. If it is true, do something. If it is false, do something else. Like here. Easy?
Yes.
Any question? Any question? No?
So,
Yeah.
how do we know to use the function and when to use the function?
Come again?
How do we know what function do we have to use and when we have to use it?
What function to use is something that you have to learn and practice. When to use is depending on your
Problem.
program. How you want to solve it. Right? For example, here you're dealing with string, isn't it? Because here, char name 20 is a string. When you're dealing with string, you are likely going to use some functions in string. So you have to include the library string.h. Right? Just how it works. Okay. This is group C. Yeah,
Yes.
I see a lot of you have not signed in.
Really?
Yes, I see a lot of you have not signed in.
You future or
You
class?
future. In you future.
Oh. How many people have already signed in?
Hold on. This is something else. No. All right. A lot of you have signed in then. We have Adib. Is Adib about? Adib?
Yes,
Okay, you have not signed in.
I just signed in a
Okay.
few seconds.
Okay. Alif, you have not signed in. And Naufal, you have not signed in. I'll check again in a bit. No worries. So what function to use? You have to try, because the thing is, you have to practice. Even I cannot remember all the questions, all the functions. But what library to use? Generally, we do not use so many libraries. These are sort of some of the libraries that we use. IOStream, string.h, what else? You will come across some other libraries in the near future. Okay?
Okay, thank you, sir.
Now move along. That was the selection control structure. Yeah, this is just an example. Telephone rings, true, answer the phone. False, continue reading in this case. Now, let's have a look at the next control structure. It's the repetition structure. The repetition structure allows a sequence of instructions to be executed repeatedly until a certain condition is achieved. Notice, if it is true, keep on repeating. until it gets to false, then only it will continue. This is called the repetition. A program control structure, repetition. Back has items. True, take item out. Back has item, take item out until everything is gone. Until everything is gone, back has item, false. There's nothing more in the bag. Then only it will execute something else. Right? Coming back to the example. If it is false, if it is true, then it's fine. If it is false, hello, you are not Suhardi, then perhaps you want to repeat 3 times, intruder alert. Okay? You want to repeat 3 times, intruder alert. How do you do that? Of course, you can do one by one, but that is not repetition, isn't it? That is you doing it 3 times, which is sensible to do it using 3 lines. But when it comes to something that requires you to enter perhaps 1,000 data, then it's not a complete or sensible idea to write 1,000 lines only for that. So the most popular repetition structure is called for. Yeah, the most popular repetition structure is called for. For this is where you put in the condition. For integer I equal naught, I less than 3, I plus plus. Oh, hold on, because we may be having problem later otherwise. Out. Intruder alert. Go. Now, the numbering in programming always start with naught. Yeah, always start with naught. It's not from 1. It's always from naught. So in this case, naught, 1, and 2, which is 3 times. All right, naught, 1, and 2, which is 3 times. Now, earlier, if you notice, I suddenly start to add the curly braces. Whereas up here, I did not put any curly braces. Why is that? The reason why is, if there's only 1 line, it's not necessary. It's not mandatory for you to put the curly braces. Whereas if you have more than 1 line, you must put the curly braces. Yeah, you must put the curly braces if you have more than 1 line. In this case, you have 3 lines. 3 lines must be encapsulated within the curly braces. Right? So this is in the else block. Let's try to run the program. Name Ahmad. There you go. You are not Sohardi. Intruder alert 3 times. Yeah, that happens 3 times. Despite we're running it only 1 line in this case, of 2 lines, it will display 3 times. The first time I is when I is not. The second time, notice I plus plus here. I is incremented by 1. The I plus plus means, which is similar to I equal I plus 1. So I plus plus equals I equal I plus 1. Okay? Understand?
Alright. Yes.
I is incremented by 1. First, I is set to naught. It will display intruder alert. Then I is incremented by 1. I becomes 1. I becomes 1. Still, I is less than 3. Intruder alert. I is incremented by 1. I now becomes 2. 2 is still less than 3. Display again intruder alert. I is incremented by 1. I becomes 3. Is 3 less than 3?
No.
No, 3 equals 3, isn't it?
Yes.
So, this statement becomes false. When it becomes false, it will come out of the loop to here and return not back to the main program. Program terminates. There you go. Easy peasy?
Yes.
Oh, right. Let's try something. In order for us to try something, let me try to put something in your classroom. We try to put something in your classroom. Right, why don't you open your classroom
Alright.
and check on lab tutorial chapter 1.
Oh, tutorial dash lab.
There you go.
Alright.
Let's have a look at the very first question. Define the input. Open in Google Docs. Right. Define the output, input, and process of this task. Now, let's work on this together. Assume that your weight is X kilogram. You need to convert your weight to pound and display it. So hint, 1 kilogram is equivalent to 2.2 pounds. Notice, we need we have the weight in kilograms. What is the input?
The input is our weight in kilogram.
There you go. Weight in kg, isn't it? That's
Yes.
input. What is the process?
Process is 1 kg equal to 2 pound. I mean, our weight times 2.2.
Right?
Yes.
What's the output?
Weight
In
in
pound.
pound.
Yeah, the LBS. I do not know what is LBS, but it's pronounced as pound.
Yeah.
Right?
It's a short form, if I'm not mistaken.
Yeah, it's probably in different language.
Yeah, it's in Latin.
Probably, yes. Now, that's done for A. Now, let's move along to B. Write an algorithm. I'm going to clear the screen. What do we do in algorithm?
First input weight. I mean stat.
All right. So I'll prefer to use get, but you can use anything. Get weight in kilogram. Correct?
Yes.
Then
Then process.
process. Obviously, then display.
Yeah, display.
Weight in. There you go. That's the for B. All right, that's for B. Previously it was for A, now it's for B.
Yeah.
All right, let's move along. Write the pseudocode. Let's clear that again. Write the pseudocode.
We put stat first.
We put always begin. Not
Yeah.
start. Begin. The
Yes.
same thing, isn't it?
Yes.
Yeah. The subsequent lines are the same, only that you have to put begin and end. So might as well. Yeah, might as well. That's for C. Move along.
Input weight in kg.
No. We understand because it is exactly the same as the previous one.
Yeah.
So we're not going to do it. And finally, we have to draw a flow chart. This is what we're going to do. So, of course, the first thing is
Oval shape.
begin. All right. What comes next?
Arrow down. Then we put prism.
Wait. Isn't it?
Yes.
Or perhaps if you want, we can get. Doesn't matter. Then
Process.
represented by
Square.
rectangle.
Yeah, rectangle.
Yeah, rectangle. So never mind. Move along.
Display.
There you go.
Weight in pound.
And finally,
N.
there you go. And any question?
Sir,
Huh?
I completely lost. I don't understand.
Look, we are trying to solve this question. We are trying to solve this question.
Yes, and I don't understand how.
This is the step that you have to do in order for you to solve the question systematically. First, we define the input, the output, and the process. So the problem that we have here, assume that your weight is X kilogram. You need to convert your weight to pound and display it. Okay? Hint, 1 kilogram is equivalent to 2.2 pounds. Is that okay with you?
Okay.
Right. Now, next, we want to answer the very first question, which is to define the output, the input, and the process. What is the input? The weight in kilogram, isn't it?
Yes.
What is the process? Here, 1 kilogram is equivalent to 2.2 pounds. So if you enter 10 kilograms, how many pounds is that?
Say again. I didn't hear.
All right. What if we enter 10 kilograms? How many pounds is 10 kilograms?
It's 10 at the 2.2 pounds.
There you go. 10 multiplied by 2.2, isn't it?
Yes.
Which is weight in kilogram multiplied by 2.2, isn't it?
Yes.
Wasn't that the one that we did earlier? Okay, let's try again. Let's try again. Input. Okay, input. What's the input? The weight in kilogram. Isn't it?
Yes. The input is the weight.
In kilogram. What's the process?
1 kg equal 2.2.
Not 1 kg equal to 0.2, but weight in pound equal weight in kilogram multiplied by 2.2.
Okay.
Correct?
Yes. Yes.
If the weight in kilogram is 10, then 10 multiplied by 2.2 is equivalent to weight in pound. And the output? Output is, of course, weight in pound. Correct?
Yeah.
Yep.
Yes? Based on this, we write the algorithm like we did earlier. First, we get the weight in kilogram. Get weight in kilogram. Next, we calculate weight in pound, which is, let's see, this is a bit big. Let me change the color to red. First, we get weight in kg. That's not enough space. Next is we perform process. Calculate weight in pound equal weight in kg multiplied by 2.2. Next, we display weight in pound. That's the algorithm. Yeah, this is the algorithm.
Okay.
Write the pseudocode. We put on begin and that becomes a pseudocode. Draw a flow chart is the one that we did earlier. So we have begin, get weight, calculate weight in graphical form. Begin, get weight, in kg. The symbol here, if you remember, is here. Notice here. This is the input-output symbol, terminal symbol for begin and end. That's the input-output symbol. That's the process symbol. That's the decision symbol. That's the on-page connector. That's the flow line. So we use exactly the same thing in here. Yeah? This is a process. This is input. Move along to perform the process, which is weight in LBS equivalent to weight in kg multiplied by 2.2. Next, we display output is represented by yet another that. Display weight in kg. And what comes after is the closing terminal. Correct? Are they not the same?
Yes.
They are the same except that they come in different forms, isn't it?
Yes.
Now, your task. How about if you implement the code in C++? Yeah, for question number 1, we've done the design. So what if you try to solve the problem? You implement the problem. You implement the solution. Meaning to say you type code. All right. Now, run your dev CPP and start typing.
All right.
10 minutes. Aiman,
Yes, sir.
can you show your screen, please?
All right.
There you go.
Do I need to run it?
Yes, please.
cancel.
I don't bother to calculate, but of course this is correct. Right? I don't bother to calculate because we understand that line number 12 clearly states that kilogram multiplied by 2.2. Then of course, it is a computer. It will perform calculation way better than we can. Yeah, can everyone agree on that?
Yes, sir.
Yeah, of course. Yeah, unless you really want to calculate by yourself, using pen and paper, by all means you can do that. But personally, I just trust the computer. As long as I get to see that the formula is correct, then I will assume that this is already correct. So, if you can see from here, notice it says double. Double is also fine. Now the reason why he used double, because double also accepts floating number. I would prefer to use float for reason being that float is less than double in terms of size. So I do not use greater space. That's why I prefer to use float. Unless you really need that really precision, that really long precision, then you can use double. But there is nothing wrong with using double or float. Okay? See
All right.
out, see in, found, see out. There you go. Now, if you look closely here, we can see that that's the input part, line number 9 and 10. That's the input part. That's the process part, line number 12. That's the output part, line number 14. Okay? So, this is just something that we expect out of you. Any question?